All right. So we learned some new calculator functions on Wednesday. And so this is just going to reinforce that. So you'll want your calculators out. Okay, so on this practice, we're told that Merck & Company is the world's largest pharmaceutical company. And net income values for the company are given below. Okay, so they give us a table. So from a table at this point in the semester, you should be able to tell me what the function and what the variable is. So which one is the function? Net income, and I'm going to call that N. Now, be more specific. What else does it say? In billions. No, that's a big number. So one would mean $1 billion. All right, that's a lot of net income. All right, so the variable is what? Years. So I'm going to call it T. Years. Okay, now one thing I want you to look at. Go ahead and write this. This is my variable X. This is my function Y. All right, so I want you to look at the variable. What is going on with this variable that we don't typically see in our table? If I had an equation, would I calculate N at 1980, N at 1989? Because if 1988 means years, if I did N at 1988, that means 1,988 years. But how was that typically worded in ones that we've done in the past?
1 year after 0.
Since, right? So let's look at the table. If we visualize this, this would represent years since when? 1988. So when we do go to our calculator, any calculations we use, we won't use the actual year. What value would go with 1988? 0. This is 0 years since 1988. 1 year, 2 years, 3 years, and 4 years. So these are going to be your variable values that you use. All right, so part A says, show that the data in the table can be monitored by a linear function. Okay, I've been stressing this, that when it says show that from a table, what are we going to do? Average rate of change. So we're going to calculate that, and we don't have to do it for every one of them. So we're going to do it for the first two and then the last two. So the average rate of change from 0 to 1 years would be 1.5 minus 1.2 over 1 minus 0. And we get 0.3. And that is talking about billion over 1 year. And then we're going to do that exact same thing from year 3 to 4. So we get 2.4 minus 2.1, 4 minus 3. So we're also going to get 0.3 billion 1 year. Okay, so have we shown that it's linear? And we know that how?
It's the same.
Okay, so we have what type of an rate of change?
Constant.
Constant. So I'm going to say, yes, it's linear. Because the average rate of change is constant. Okay. Find an equation that represents the net income in as the function, which is what we defined at the top of the page, time t since 1988. And this would actually be years t since 1988. Okay, so find an equation. So we know our linear equation is y equals mx plus b. But of course, y is our function and we define the function as n. The slope we just calculated, 0.3. X is t for time in years, and then plus b. All right. So now we've got our slope, but what is the next value we need to find?
Initial value.
Initial value, and how do we do that? Plug in an ordered pair, right? Okay, so if I looked at the ordered pair, the variable is always first, so that would be t, and then function, which is n. Okay, looking at my table, how many ordered pairs do I have?
5.
1, 2, 3, 4, 5. I have 5 ordered pairs, and I would use 0, 1, 2, 3, 4 as my x variable. Okay, so I have 5 ordered pairs. Does it matter which one I choose?
No.
No, they would all yield the same answer. I typically choose the first one. It does not matter. So what is that first ordered pair? Now, I'm going to plug it in and calculate for B, but let me ask you something. Does that ordered pair automatically give me?
Yes.
And how do I know it gives me the initial value? Because the variable is 0. So if the variable 0, this is your B. Okay, I'm going to go ahead and calculate it. That way, if you did not recognize that, you know still what to do. Okay, so in place of n, we would put 1.2. 0.3 times 0 plus b, and we know anything times 0 is just 0. So we get 1.2 equals b. So this is our initial value. So now we're going to write the equation. And the equation is going to be n equals m times t plus b. Now, you don't have to write this and show me this. I just like to do it in notes so you know where everything comes from. When I go to substitute numerical values into this equation, am I going to put a number in for every letter? Okay, which ones do I substitute with a numerical value? Only the slope and only the initial value. So my equation is n equals 0.3 t, and this is positive, so it would be plus 1.2. Okay. Okay. So the first part of part C says graph the data from the table. All right, so let me go ahead and draw and label my vertical and horizontal axis, and then we'll go back to the calculator and refresh our memories on how to do that. So we have N, which is net income in billions. And we have P years since 1988. Okay. All right. So to graph the data. Okay. So first off, before we even get started, I want you to go into y equals, and if you have an equation in there, clear it out. And then the next thing I want you to make sure of is that that plot 1 is highlighted. If anybody's not highlighted. We're all good there? Okay. So how do I enter? So here's the data that I want to enter. And the variable is always list 1, and the function is list 2. Okay, so what, well, let me go to quit. Let me go back here. Okay, where do we go so we can enter our lists? Stat. So we're gonna hit stat, be sure it's on edit, which it should always go there, and whoever said 1, yes, that's what we're gonna do. All right, now a reminder, so I have some numbers in there. If you want to clear out numbers, highlight the list and then push clear, do not push delete, and then down arrow, and it'll just clear those all out. Okay, so then I'm going to go back in and then list 1, 0, 1, 2, 3, 4. List 2, 1.2, 1.5, 1.8, 2.1, 2.4. Now, quickly look at it and make sure that you have the exact same numbers, not the list both has 5 numbers is what I'm trying to say. Because I had a student in my earlier class that theirs wasn't graphing, and we looked and they had accidentally put a 5 in there. So they had an additional number in list 1 that they didn't have in list 2, and it messed up when they tried to graph. Okay. All right. So we put all those numbers in. So what do we go to now? Zoom 9. And you get something like this. Okay, so I am going to come over here. 1, 2, 3. You should have 5 ordered pairs. It actually probably goes up more, but it would be fine. Okay, now, one thing before we move on, I want you to notice. The initial value is 1.2, 1.2 billion. Billion is here, right? So if this is 0, it makes sense that it's above. So it's not right in the corner because your initial value is 1.2. So just make sure that those things you recognize and that things make mathematical sense. Okay. All right. Anybody had any trouble? They weren't able to get that scatter plot. We're not in y equals. We'll clear out that. Plots on, so we go to stat 1. We got to put these numbers in 0, 1, 2, 3, 4. Then you're going to put in 0, enter 1, enter 2, 3, 4. Right arrow over. I'm going to put in 1.2. Enter 1.5, 1.8, 9. All right, anyone else? Okay. Hey, remind me after class, I want to ask you a quick question, okay? All right, so we've done graph the data in the table, all right? So then it goes on to say, and add the linear function. Okay, well, that means that if I want to add a line, then I've got to put my equation in. So where are we going to go to next? Y equals, which is up here. And now we're going to enter this equation. So the one I just deleted on your calculator, now you're going to go in and put it there. So you're going to put in 0.3x plus 1.2. So we put that in the Y1. And then what do we hit? Graph.
If I find that by using the table.
What do you mean? You can't look at a table and it graph a line, so I don't guess.
Like, to find the number for the.
I'm not on D yet.
Oh, I guess.
Okay, so then we hit graph. Okay, And so then I'm going to go and draw that line through all of my points. All right. Based on the data in the table, would you expect Merck's net income to be, or what would you expect it to be in the year 1995? Okay, what did they give us?
The variable.
Okay, so we're given the variable, bless you, value, and the variable is T. So does T equal 1995? No, it's 1995 since when? 1988, so it's actually 7 years since 1988. Okay, all right, so this is my variable value. How would you write that in functional notation? In at 7. Now, and then this is where Brett was asking this question. So what I'm going to do is use the formula that we found, which is 0.3 times 7 plus 1.2. And what does that calculate to be?
3.3.
3 point what? 3?
Yes.
And what is that? 3.3 billion dollars. Yes, if you want to pull that from the table, unless the directions told you to do otherwise, yes, you may. Just be sure to make notation of that if it were a test, so I know where you pulled it from. Okay. All right, y'all. Okay. Pause. Billion? That is a lot of money. That's a lot of money a pharmaceutical is making. Okay, how much do you guys pay attention to the news? Or commercials, which you probably don't with commercials, you probably flip it or whatever, but is there a pharmaceutical company that has become that name I have seen over and over and over since 2024 with advertisements? Travis Kelce. Y'all watch TV any? What do you do? If you don't watch TV, I mean, like, do you ever just chill and watch something? I mean, do you watch Netflix, Hulu?
Yeah.
Okay, do you do it commercial free or with commercials?
They pay, no, commercial something up.
Okay, so yeah, YouTube, my girl that I work out with every morning, and I'll get commercials every once in a while. So I do think there are probably commercials on there. Okay, Pfizer, have you heard of Pfizer? It would be interesting to know because it would not shock me if their net income has not been that or more. So anyway, now you know how you don't pay attention to a color of vehicle until you buy that color, and then it's like every vehicle on the road is that color. So now every time you see a Pfizer commercial, you're going to think of me. We just talked about it, right? So yes, they are making a lot of money. Okay, so that finishes 3.3. That is due tonight in WebAssign. Okay, so be sure that you are completing those assignments. Okay, starting 3.4, this will not be part of the content that is on the quiz that you take. Okay, all right. Determine whether the data below are linear. Okay, we were just doing that, so let's do it again. We know this is our variable X. This is my function Y. And when we determine or we show whether it's linear, we do that by half. We're going to use the average rate of change. So we'll do it for the first two and the last two. And when I look, this is T time in years, but they gave me 0.2468. So I don't have to convert that. Okay. So average average rate of change from 0 to 2 years. It's the difference in your function, which is 14 minus 10 over the difference in your years, which is 2 minus 0, not 1. So we get 4 over 2 or 2 over 1. Is that what you get? So population, I don't know what units that's in, over 1 year. All right. So then we're going to do the same thing from 6 to 8. So we would have 31 minus 23 over 8 minus 6. Well, that's 8 over 2, which is 4 population over 1 year. Okay. So is it linear?
No.
No. No. No. Because leave some room right here. We're going to create a graph. The average rate of change is not constant. All right. So it's not linear. Now it says plot the data. So I'm going to create a little graph here. This is N, which is the population. I'm just going to put pop because I ran out of room. And this is T, which is years. Okay, so I'm going to go to my calculator. I'm going to go to Y equal, and I'm going to get rid of that equation because I don't have an equation for this one. So we go to stat 1. Okay, now again, so be sure you're listening up on this one. I'm going to up arrow and highlight the list, and then I'm going to push clear and then down arrow, and all those numbers are gone. I'm going to go over and highlight list 1. I'm going to push clear, and then I'm going to down arrow, and all those numbers are gone. So now my list 1 is it 0, goes by 2s. So it's 0, enter, 2, enter, 4, 6, 8. Right arrow over, and my list 2 is 10, enter, 14, enter, 20, 23, and 31. And I make sure that I have an ordered pair and I don't have extra numbers. And then what do we hit? Zoom 9. And we can see that it's not linear. So it starts out at an initial value. So maybe kind of like that. So is it an exact linear relationship? No, or every point, every ordered pair would fall on the line. Does it have a resemblance of a linear relationship? Yes. So that's what we're including today. Okay, so what we're going to be using now today to find on our calculator is what we call a linear regression equation. So we've been finding equations, but they were linear. Okay, this is a linear regression. Okay, what does that mean? Linear regression is an approximate model. So not exact, but an approximate model for the data. An easier way to say that is we are going to find a line of best fit. So it does appear to have a linear relationship. All the points won't be on the line, but we can find an equation that is our line of best fit, and that's called your linear regression equation. Okay, so I'm going to show you how to do that. All right, we've already entered our list 1 and our list 2. We have already plotted the data. So we've already done that. Okay, this next step is what is new. Where it says press stat. Now, when we went to put in list 1 and list 2, we pressed stat and then we chose to edit, correct? Okay, well, now what we're gonna do is we're gonna right arrow over to calculate. And then I want you to look down to number 4, and what does it say? Lin reg, that represents linear regression. Now, look at what's in parentheses. Does that look a little familiar?
Yes,
What do you think of when you see that?
and that's supposed to be.
I do too. Y equals mx plus b, and that is the relationship, okay? So for your calculator, your slope is A, not M. B is still your initial value, okay? So we're gonna put 4 in. And then it should have list 1 and list 2. If it has a different list in there, we need to change it. But all you have to do is push enter, 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 get down to calculate. And then hit enter. And so based on our calculator has y equals ax plus b, where we're familiar with y equals mx plus b. So from my calculator, then my slope, which we use M, the calculator uses A, it tells us it's 2.55, right? And then our initial value, we use B, and so does the calculator, and that's 9.4. So now I have the 2 pieces necessary to write an equation. So my equation is my function, which is n, equals slope, which the calculator gave us was 2.55, times the variable, and in the table, my variable is t, and then the initial value is positive, so we would do plus 9.4. Now, let's go ahead. Then I want you to go to y equals, and I want you to put in this equation, 2.55x plus 9.4, and then what do we push to see what it looks like on our scatter plot? Graph. And so there is your line of best fit. So you can see it goes through some of the ordered pairs, but not, actually, it looks like it only goes through one of them, doesn't it? So then when you go to draw it, it might kind of look like that-ish. So that's what we call the line of best fit, which is linear regression. Okay, so everybody good on the calculators with that? Okay, so let's go to example 2. So let's go ahead and clear out our data and clear out our equation. So again, cursor over the list, clear, down arrow, cursor over the list, clear, down arrow, and then get back to your screen. Good. Does anybody need any help? Okay. The following data or table shows the length in meters of the winning long jump in the Olympic Games for the indicated years. All right, so we know this is our variable. This is our function. We know that this will be list 1 and list 2. Now, when you're looking at the table, this is similar to the one we talked about earlier. The year would be what? And so what would you write? Year is since 1900. So this would be 0. Now I made this error in my 9:30 class. I went 0, 1, 2, 3. Is that what's going on here? No, what would this one be? 4, 8, and 12. Okay. All right, so it doesn't ask me to do anything yet. Okay. Find the equation of the regression line. Okay, do I need to put my points in right now to do this? If I don't, does my calculator have anything to calculate from? No. So what's the first thing that you're going to have to do? You're going to have to enter your lists. So in order to find this, you need to enter your data in the calculator. So again, that's stat 1. And list 1 would be 0 enter, 4 enter, 8 enter, 12 enter. Right arrow over. 7.19 enter, 7.34 enter, 7.48 enter, 7.6, and if you put 60, that's fine. Enter. Okay. Now you could go to Zoom 9 and it would look like this. Let's go ahead and look at that. But is that what this question is asking me for? No, it asks for the equation. So that's the one that we just learned. So where do I go? Okay, I'm going to go to stat. All right, so I'm going to write that over here. So the first thing we did was stat edit. And then we entered list 1 and list 2. We went ahead and did Zoom 9 to see what it looked like. And so now we're on stat. So I'm going to go to stat and then what? Whoops. Okay, I'm going to go to calc. And then what? And then hit a whole bunch of enters, right? Enter, 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 enter. Okay, so again, they give us the slope, which we call M, but the calculator calls A. I'm going to go 3 decimal places. So 0.034. And then our initial value is B, which so is the calculator, 7.197. Okay, so now I have all the pieces, okay? All right, now notice that it did say that the length is, so that's using L, and T is what is being used for the variable, okay? So my function is L equals slope times variable T. And then my initial value is positive, so plus 7.197. Okay. All right. Explain in practical terms the meaning of the slope of the regression line. Okay, so my slope is 0.034 over 1. So now I'm going to take a look at my table. And 0.034 is what? What would you label that as? Meters. That's your function. And this is 1 what? Okay. Now I'm going to have to be a little bit, give more information in my explained. Okay, so I've got to talk about the function. Okay, so what is this the length of? Oops, I can't spell that. The length of the winning long jump, be more specific. In the Olympics. A little bit more specific. What do you think I'm looking for? Since 1900. Is, okay, now I want to think towards the numbers. What's first important to notice about your slope?
Positive.
It's positive, so we know it's increasing. So it's increasing 0.034 meters per year. Okay. All right. Now, the next page is the C, D, and E, so it's still on this Olympic Games, so have that handy where you can see it. Okay, so it says plot the data points. Well, we already put them in there, right? So I'm gonna go back to Zoom 9 and it should give me my picture. So. Let's see, this was L, which was the length in meters. And this is T, years since 1900. So I know when zero's here, that is the year 1900, okay? All right, so I have 4 ordered pair. Those look more linear than the last one. This one does look like it's down a little bit. So. Oops. Here. Looks like it goes up a little bit and down. Maybe something like that. Looks pretty linear. More so than the other one. Okay, so we've plotted the data points. And now we want the regression line. So where do I go? Y equals, and I have not put that in there yet. Let's see, what was it? 0.034 x plus 7.197. And then what do we hit? Graph. You can tell the line's a little above the initial one, that it's just under the next two, and then it looks like it's right on the last one. So kind of like that, not exactly, but you get a good idea. Okay. Did you get it? Did you get the scatter plot? Did you ever do Zoom 9? Okay, well, they're both there now, so I don't know what happened. Okay. All right, so part D is a thought process question, okay? And we had an interesting conversation. Listen to my. Maybe I didn't work out there. Because, okay, so it says, would you expect the regression line formula, which again was L equals 0.034 T plus 7.197. Am I remembering that correctly? Is that right?
Yeah.
Okay. So it's asking, so this was created off of the values from 1900, 1904, 1908, and 1912. That was a long time ago, right? So would you expect this formula to be a good model of the winning length over a long period of time? Do you expect from the year 1900 that it will continually increase at 0.034 a year? Okay, why do you think no?
So it wasn't constant.
Because why?
It wasn't constant.
It doesn't matter if it's constant, right? One year they might jump a full, half a meter, the next one, but this is a best fit. So based upon the best fit, do you think since 1900 that they would have an increase of approximately this every year?
Well, there has to be like a length if they can't. So there has to be a max.
Okay, so there has to be a max, right? Because we can only do so much, right? So, 200 years from now, is it still going to be increasing 0.034? So we had this conversation in my 930, and what was interesting was, I had a student who actually looked it up on his laptop at what the Olympic record is, and it was like was it 7 something or 8 something? I don't remember. Let's see, men's long jump Olympic record. Okay, it's 8.9. 8.9. All right, but here's what was interesting is that was set. Oh, I thought he said 1991, but I'm seeing 1968. No, yeah. So, which then means, so whether it was set in 1991 or 1968, I'd have to do further, and I'm not going to do that right now. Has it continually gone up this every year then? No, they've actually jumped less than that. So there is, like Samantha was saying, there is a limit to this, right? It's not going to continually go up and then they're going to be jumping 15 point something, right? So the answer to this would be no, because there is a limit to how far a person can jump. And like I said, regardless of whether it's 1968 or 1991, that record has held. And so it has not continually gone up. Okay. All right. So there were no Olympic Games in 1916. So if I went back here and if I just extended this and did 1916, this was 16 years, but we don't have any data for this because of World War I. Okay, so there were no Olympic Games. The winning long jump in 1920, so in 1920, which would be 20 years after, right? We know that the value was 7.15 meters. So this was what was jumped in 1920. Okay. All right. So compare this. So in 1920, I'm just going to do this. They jumped 7.15 meters. That's what it looks like on that table that I went and extended. Compare this with the value that the regression line model gives. So what it's saying is compare the actual jump to what you get if you were to put it into our regression line model. Was it 197? Yes. So how would I write that in functional notation? L at 20, right? Not 1920. We're doing L at 20 years since 1920. Which, what does that give you?
877 meters.
Yeah, so based upon the regression line that we got, this would be what we would have predicted. This is a prediction of what we think they would have jumped in 1920. It was not exact, but it's not way off either. So it was, in my opinion, it would be a decent prediction. It's not exact, right? Because this is a prediction. The likelihood that it's exact is gonna be pretty slim. But, is this result consistent? I would say, yes, it's not far off. All right. Okay, so that finishes that. That's a great stopping point. So let me turn this off.